G'day guys, here we are at the number 19 hex block. Alright, straight into this one. First off, rectangle tool. Let's get the footprint. So we've got 80 by 100. Pretty easy. 80, 100, enter. Alright. Now we need to push it up. What is the total size? We've got 120 millimeters. How bloody easy is that? 120, enter. Look at that, good stuff. Alright, now the easiest thing to do here, I reckon, will probably be because we've got almost like a C shape. If we look from the top, we've got like a C shape that goes around it. Obviously there's slopes on it, but if we make a C shape with a hollow sort of inside, we'll put that slope in later. If we make a C shape with a hollow inside, that might be easy to get started and then start laying out our slopes. So the slopes seem to be, the C shape is 12 millimeters wide, 12 millimeters wide, 12 millimeters wide, and it will be removing the center part down to 12 millimeters thick. So this remaining part here will be 12 millimeters thick. So we can use the tape measure on the top surface to measure 12 millimeters in, 12 millimeters in from that back corner, and 12 millimeters in from this corner over here. Then we can use that magic trick I showed you before where you grab the line tool, click on your guide point, get on that red axis, then hold down the shift key, and then we can line it up with that dot. Click, then we can start from here. We can hold down shift, get it lined up with that guide point again, click, and then click. So see we've got that C shape. Now we need to remove the center part down until there's 12 millimeters left, like we said earlier. It says it over here on the drawing. So we'll go from the bottom, measure 12 millimeters up, click on this surface here, and drag it down to that guide point. There we go, looks pretty good. So let's get started on, say, this left slope. I think there's enough information to get started on that. We know that the top of it is 90 millimeters up, and then the top of the slope is 12 millimeters in from the back, and it slopes down. The bottom of the slope just comes right to the edge, 12 millimeters up. We've already got a dot there at 12 millimeters up. All we need to do is grab the tape measure. We'll put in the 90 millimeters up. There's our guide point. 12 millimeters in. And then I reckon we could just do a bit of dot to dot. What do you reckon? There to there to there. Right? If we push that in, I think it'll stop us at 12 mil. Yeah. And we'll just need to use the eraser to get rid of that line and that line. There we go. That looks like that slope's pretty well done. Okay, let's do we can't really do the back because it's we need to do a circle, but it's blocked by this wall. So we might need to do this wall. And to do that, we're going to need to measure off the top of this slope, off the top of that 45-degree slope. So let's put that slope in. We can see there's a flat spot there of 12 millimeters, and that's where the bottom of the slope is. And we can see it's a 45-degree slope. So from here, let's measure in 12 millimeters. And then we'll grab the protractor tool here. We want this to be on the green axis. So if it's not on the green, just use the arrow keys. I think it's the left arrow key to get it on the green. Click once, click all the way to the top, make sure the line's blue. Start dragging it across, and you'll see the angle come up at the bottom. We want to type in 45, enter. And there's our 45-degree slope. So if we just trace that dotted line from there to the intersection, we can then pull that point away from there and get in the slope. Look at that, how good. All right, so for that back wall, we need to find the top of the slope, which is 12 millimeters there, and you've got a flat spot of 12 millimeters. And then the bottom of the slope, it is 24 millimeters from the bottom. So we know that that is already 12 millimeters thick. So let's go another 12 millimeters from here, which will add up to 24. Seems like everything in this drawing is in multiples of 12, isn't it? 12 and 12. Again, I think we can just play dot to dot with the pencil. Dot to dot to dot. Right? And then if we push this wall away, look at that. That is looking pretty well ready to put in that radius up the top there, or that sort of half circle. So we can see the information about that. The radius is 20. We'll worry about this hole later. And the slope meets it at the tangent point. So when we lay it out, first thing, we need to find the center point of the arc. So that'll be 20 down and 20 in. And so that's the center point of the arc. We'll grab the arc tool. And we can't, we're on the red face, that's good. We can't just click, click, and stop there at a quarter circle because the tangent point won't actually meet it there. The tangent point will meet somewhere around here. So just to be safe, let's draw a half circle. Then we can put the bottom of the slope starts over here at this point. And if we zoom in, we'll have to just check where our tangent point is. So we can go higher than that, maybe higher than that. Nope. See, if we go to the next point, it starts cutting through the circle, which would indicate that that there is our tangent point. Anywhere further, it starts cutting through the circle. So that there's our tangent point. We'll click there. We can use the eraser to erase that line because we don't need it. And we can use the push-pull tool to get rid of that and get rid of that. Okay, looking good. Now, we'll just get rid of this little circle here. That's a diameter of 20 and 6 millimeters deep. So grab the circle tool. If the diameter is 20, then the radius will be 10. Good work if you guess that. Now, we'll push that in. How far to say? 6 millimeters. Pretty good. All right. Now, okay, we've got a 20 millimeter circumscribed radius for that hexagon in the middle. See this hexagon we've got to remove? That's a 20 millimeter circumscribed radius. Now, this is going to have to be another solid tool subtraction removal to get rid of that, which can be a little bit of a pain, but you know, we'll figure it out. So what we're going to have to do, we're going to have to make this a component similar to we did in an earlier drawing. So if we highlight that, right click, make component. So that's a solid bit. Then what we'll do is we'll make a, I guess you can call it like a hexagonal cylinder. And we'll put, if we put that through the shape and then remove it from our original model, that will leave us with that sort of hollow hexagonal bit. So first of all, we have to lay out the where the circumscribed 20 millimeter circumscribed radius hexagon is. Geez, that's a mouthful. So we can see that it is 12 millimeters up along the slope and 38 millimeters in from the edge. So 38 millimeters in from here, we'll measure our guide point. From here, if the line goes purple, it means we know we're going along the slope, so that's good. Type in 12. Now, let's see. Now, I'm not going to pretend like I know the difference really between a circumscribed and I think it's an inscribed radius on a hexagon. The tool we're going to want to use is not the circle tool, it's the polygon tool over here, right? If we use this polygon tool, the first thing that you need to do is to enter the amount of sides you want your shape to have. I think it automatically defaults to 5 sides to draw a pentagon, as you can see down here. Mine is 6 because I've used a hexagon recently. But all you have to do is just type in 6, enter, and then you're going to be drawing a 6-sided shape. So I'll just show you the difference. If I click over here and start drawing one, see how it's telling me I'm using an inscribed radius? That is the length from the center of the hexagon out to one of the corners. Whereas if I hit Control, it changes to a circumscribed radius. So that gives me the measurement from the center of the hexagon to the middle of one of the edges. Okay, so we're using this one, a circumscribed radius. So we need to, I'll just hit escape to get out of that. We need to measure from this point 20 millimeters straight up in a line. So we'll be on the blue axis, 20 millimeters. Okay, from here, we need to grab the hexagon tool, make sure your side says 6. If it doesn't, hit 6, enter. Then the hexagon's looking a bit funny at the moment. The lines are black on it, whereas we want it to, I think we want it to be red because we want to be drawing along the red axis. So I think we have to hit the right key. Yeah, the right arrow key will make it red. Then we're just going to go straight down to that point. But see how we're on an inscribed radius? We need to hit Control and make it a circumscribed radius. So once you're on circumscribed radius, click. This is a funny word, isn't it? Circumscribed radius. Okay, that's looking good. Now what we need to do is we need to push this shape all the way through so it comes out the back. And then we'll just push it a little bit past over here. All right, so that's looking pretty accurate. I reckon if we remove that shape from here, it'll leave us with the perfect finish. So we need to, it might be a bit tricky to highlight this thing by clicking and dragging because we might accidentally highlight this. So quick trick, if you triple click, 1, 2, 3, it highlights the whole thing. Trick, and then right click and make component. Component number 2 is fine. There we go. Now my solid tools are hidden over here. So I'll just grab that and widen it up a bit. Oh, sorry, I'm covering out the drawing, but that's okay. That's the tool we want to use, the subtract tool. It's going to subtract the first solid from the second and keep only the result. So that's the first solid, which I want to subtract from the second. So I'm going to click on that tool, click on my second solid, and boom, look at that. That is one good looking number 19 hex block. I think that's all done. Can you see anything I missed? I don't think I missed anything. That looks pretty good. Cool. So what do? Edit, delete guides, and then we save it. So we'll go File, Save, find your folder, My Drive, CAD Activities, and we'll call it number 19 hex block. Yeah, perfect. Okay, we'll go File, New, and look at this. We're on the last one for this series. Isn't that exciting? So number 20 pivot bracket. I'll see you over there.